All right. Yeah, welcome back again. I want to continue from where we stopped. Last time, we were able to do a comparative analysis on a t-test using the result we got in R and the result we also got through past. So we tried to compare the results. That was last time, or last class, to see which one is accurate. We see that both of them are the same. So that's how to validate the past result to let you understand that the past result is authentic. So you can count on past. So that's exactly what we did last week using t-test. So having verified that, we can now continue to perform more statistical analysis using past. All right. So today we want to also look at the one we did last time using just t-test, single t-test. Is because the data we used was statistically significant. I mean, was rather was it passed parametric assumption. It passed parametric assumptions. In some cases, the data set may not pass parametric assumptions, right? We use Shapiro, it passed, and we also use what they call it now, normality check, and it passed. But in this case, it may not pass. For example, let us look at the same data we use. We used a mice last time. This is where we used last time, but this also mice also, but this data is different from the former one. So let's try this data also. I copy to pass and test this also to confirm if we can also use the same method. Okay, as usual, don't forget paste here. All right, so we remove this. We really need this. So let's first plot and check let's first check the normality check first and see what our Shapiro gives us. Shapiro 0. Can you see this is highly significant? So that failed Shapiro test. If failed normality check, okay. So that is no, that one is enough. But we can also check for normal. If we check for also we can check for outlier test as well. All right. And you see that one is 0.008 also failed. In fact, if you check for multiple outliers, also can see that yes, here. We only have 2 no's, okay, which means it failed. All right, it failed as parametric assumptions. So what do? We have to apply non-parametric assumptions, which is called Wilcoxon. All right. So Wilcoxon single rank, single test. You are going to perform that now. Wilcoxon single rank t-test. All right. So we call this Wilcoxon single ranked single test. So it's a non-parametric alternative to one sample t-test when the data cannot assume to be normally distributed. All right. So it is used to determine whether the median of the sample is equal to the non-standard value or theoretical value, or we call it a reference value sometimes. Okay, depend on the language, which one you are using. All right, that's exactly what we want to try to discover. So we want to see if it is correlated. So I try to see if the don't forget we can bring up as a hypothesis from there. But I want to check if the median, because now this ranking is based on median, not on mean. Don't forget the t-test we perform parametric base is based on mean, but this one Wilcoxon is based on median. Okay, it's a median. So if the median, okay, of the mice is equal to a particular value which we are going to supply, which is our MU, okay, or we call it a reference value or theoretical value, all right, or we can call it standard value. If not, if there's no value, 0 is the default value, okay, if it's equal to 0. So now that is just basically t-test, all right. So I don't want to go to the theoretical part of it. So let's just now perform the test now. So if you cannot use last time we used simple t-test. So if you click here now, for example, this place. Now that time we supply value here for t-test because we are the data was significant, was past the parameter assumption. So now we click here now under Wilcoxon test to perform. So we can supply usually to 25 last time. The same thing we supply. okay, last time for parametric test, t-test, so we can use the same thing and compute here, right? You can say our value here, simple median, not mean. Before once it was mean, it was simple median. So we got 20.4. Our Wilcoxon is 465. Then our p-value is 0.01, which is significant. Okay, and the median are significantly different. All right. So what if you have 0? Don't need to test in R anymore, because we usually have the same answer. Okay, so maybe you can do that on your own if you like, but you don't need to do that. I've confirmed that myself before I came that the same answer we got. So, and the last time we did it, I showed you how to get that. So we compute with 0. Okay, that is a default value if there is no any theoretical value supplied. Okay, so this is how you got your consultant. That is, if you are not assume for a parametric test, you just use non-parametric method, which is called Wilcoxon t-test. So this is how you apply that for single t-test. So whatever you get now, the same thing we do for 25. That's what we see I did doing here last class. So we should just repeated the same thing, but we have different result now because we are using different approach. Okay, so if your data set cannot assume parametric test assumptions, just switch auto non-parametric test, which is called Wilcoxon. It's perfect. So just get your result and compete on it. So thank you so much for listening. I will see you in the next class.